But if not, you're welcome to hang out here and watch the main presentation. I've been successfully able to have both open on my computer at the same time. So we'll move on to Stanton. Okay.
Okay. Well, good morning, everyone. As Jen introduced me, I'm Bill Stanton. I am the IV&V project manager here at Fairmont. Just a little bit of information about myself. I've been here at the IV&V program for 6 years now. Started off as a analysis analyst. And, had made my way into managing IV projects. Currently the project manager of the Solar Pole Plus project that's being developed by the Applied Physics Lab under the Living with the Star program and managed out of Goddard Space Flight Center. Prior to coming to the IV program, I worked as a software engineer, developing software for satellite ground stations. So today I'll be talking with you guys about mining technical issue memorandums for knowledge. Wanted to, if I may, start a discussion in terms of talking about possible challenges and possibilities for doing this. Let's see, grab the navigation here. All right, in terms of the structure of the presentation today, we'll give a brief background on what a technical issue memorandum is, for those not that familiar with the IV&V program. Talk about the value of mining these TIMs, and what problems might there be for a solution for mining these TIMs, what the needs are of that solution, available technology that we could use for a solution, possible scenarios, somewhat of a vision of the solution, and talk about potential next steps towards a solution. So a little bit of background. The IV program has been around for 20 years now, and through its history has found a significant amount of defects in software development, all phases of software development. When we communicate these defects to the developer, we do that using a document called a technical issue memorandum. Let's see. So I'm going to be talking. The basis of this discussion will be from that context. Although I believe what I'm going to be talking about today could be applied to other organizations outside of NASA IV&V, other possible software assurance organizations, even development organizations, or organizations that use software in operations. Basically any organization that has a repository to track defects found in the software. So along with communicating these TIMs to the projects, we use a database to help track these TIMs in terms of developing them, and then once they are submitted to the project, tracking their closure towards resolution. Our scope is limited to software development, mostly because our charter is to analyze software in development to help prevent issues being realized in operations for mission and safety critical software. And also a brief note here is we are in fact already mining these TIMs for knowledge. Our program uses metadata about these TIMs to help build metrics that ensure that we are providing a valuable service to our stakeholders. The things listed here are a couple of things that we try to answer and use that information to help determine how well we're doing. So, before I go any further, as I proposed this topic, I realized there might be a possible connection here in terms of the setting at our workshop, at least for those here local, where we are right now. So, as you guys are probably well know, what the main industry of West Virginia is mining. What we mine for is coal. So I thought I'd try to provide an analogy for mining technical issue memorandums to mining coal. So we mine the earth for coal, and now it gets to that. What I propose is that we mine in TIMs for patterns, and I'll get a little bit more into what a pattern is here. Once we mine the earth for coal, we use the coal for energy. And once we find these patterns in TIMs, we can learn from and apply these patterns to our daily work here in IV&V or for the organization of choice. So similar for coal, once we have that energy, energy makes our lives more efficient. Refrigerators, what have you. Knowledge that we gain, similar to that, knowledge that we gain from mining TIMs, I claim will make the program more efficient. So, question posed here is, what can we learn from the past? And by the past, I mean the past is stored in our repositories of TIMs that have been generated over the past 20 years. So the list that I have here by no means is an exhaustive list, but just a list to try to prompt ideas and discussion. Some of the things that I've listed here we can learn from is what are the most frequent issues found for each phase of the software development lifecycle. So with that knowledge, we can determine, all right, what processes do we have in place that are doing well, and maybe what processes do we have in place that should be finding types of issues that we're not currently finding. Something else we can learn is the most frequent recommended actions for resolving a specific type of issue. So in that case, if we're finding that there's this above all others, there's a specific action that is most commonly recommended for a type of issue, we could possibly take that action and turn it into a more proactive stance and help prevent these defects from even being found by integrating that action into, or communicating that action to developers and helping them integrate them that action into their standards for developing software. We can, by mining TIMs, we can come up with new categories of TIMs. We can come up with rules for characterizing a TIM. One of the things about, at least for our TIMs, is that I would say they're semi-structured. They do have a structure in that there are a certain number of fields for a TIM, such as phase bound, phase introduced, severity classification, that sort of thing. So in that sense, there is some structure to it. There's also fields that are unstructured text. But using some of these fields that we already manually use to classify our TIMs, we can mine these TIMs to determine rules. Example would be using one of our textual fields of a TIM is what the impact is of an issue. So if we pair that with the severity, we could build a rule for what is the proper severity level for a given impact statement. Okay. So once we obtain this knowledge, how can we use that knowledge? Again, not an exhaustive list here, but just something to try to stimulate thought, and maybe I'm kind of prompting hopefully a good breakout session afterwards. So we can share what we've learned with the industry, share our most common issues found, along with their most popular recommended actions. We can aid analysts in characterizing a new issue to gain efficiency with writing these TIMs. It does take a certain amount of effort for analysts to write TIMs, and especially to write good TIMs. So if we can streamline that in any way possible, I think that would be a bonus. We can inform scope of work decisions for new IV&V projects by helping us determine the type of issues that we typically find for projects that are similar in nature to possibly a new project that we're coming on board with. We have a function in our program that audits TIMs that have been written to determine that our TIMs are of high quality, and we can mine TIMs to help that audit process and streamline that as well. We currently categorize our TIMs by issue type. There possibly, in some instances, these types might still be too high level or too coarse-grained. Using mining techniques, we could come up with a more high-fidelity issue categorization. So some challenges that we face, I think. Again, not an exhaustive list here, but over the 20 years, at least for our organization that's been in business, a TIM has not been consistently categorized. There have been multiple ways to categorize a TIM. Fields might mean different things, have different guidelines for their content and that sort of thing. So this could pose a problem in terms of, it might be a sense of comparing apples to oranges in terms of the TIMs that we create now might not have the same look as the TIMs that we were creating in the past. Not all of TIMs that we have created over 20 years are at our fingertips. Older TIMs have been archived. TIMs are stored per project and are not correlated across projects. And just by being in this line of business for 20 years, we have amassed a significant amount of TIMs. So there's a lot of TIMs to go through, which is a time-intensive effort. So any solution for being able to mine these TIMs for more knowledge, one of the key needs of that solution is to not have a high impact into the amount of high impact in terms of effort, in terms of taking away time that we have already allocated to our IV&V projects, as well as program support. In that sense, we would need to look towards being able to mine TIMs automatically rather than manually, or semi-automatically. Obviously, some manual analysis will be needed to help determine that this knowledge was mined correctly. A solution that assists the user in building predictors that automatically learn from the user-specified set of TIMs. Applies these predictors on any user-specified set of TIMs. A solution that can be easily modified to other collections of defects or other types of data. So what's that saying there is, say we want to apply this this solution on something other than TIMs. It would make sense to do that without having to re-engineer or re-architect the solution. A solution that any analyst could use. Part of the thing I'll get to with technology is the technology is available, but it does take a significant amount of a significant upswing or curve to really understand these algorithms and techniques. So in terms of building the right tool, that takes some expertise, but in terms of using it, we would want that to be available to any analyst. So technology is available. There are tools that implement algorithms efficiently and quickly for mining text, that process text documents such in ways that here are tokenizing them, basically breaking them up into words, removing the white space, removing any stop words such as the, a, that sort of thing. Making case consistent stemming words. This stemming has to do with if you have, see if I can come up with a good example here, like verb tense, plural, we'll remove the plural and make that word the same word. And then transforming these text data into vectors. By vectors, you assign a weight to a word. And that weight would be an indicator of the importance of the word to a document. The example of that is TF-IDF here, which is a common weighting strategy for text mining. Once you have these vectors, there is algorithms and a good amount of tools that implement these algorithms for mining data, comparing these vectors for similarity, and as well as algorithms for learning from this data. If we provide a classification for a given document, text document, we can use algorithms that would build a model for classifying new documents. So one one scenario I wanted to kind of walk through here for using a solution such as this would be taking a collection of TIMs that are similar from the type of issue. In this case, these are all issues related to incorrect code, and further refining them into new categories. So just, the numbers aren't significant, but just to help illustrate possible vision of the solution. So we have a set of, in this case, a set of 600 TIMs. They're all similar in that we're all classified by the analyst as being an incorrect code issue. We feed this set of TIM into our system, and we want to basically have the system categorize these TIMs for us. We choose the field, the text, the unstructured text field that we want them to categorize it on. A couple possibilities would be the subject of the TIM, possibly the recommended action that was proposed for the TIM. The system takes roughly a minute to automatically separate these TIMs into 30 clusters. An analyst is able to view these TIMs assigned to each cluster and determine which TIMs do not belong to that cluster. One thing that I would envision that would also be available, I don't have it here on this slide, would be the analyst is able to see why these TIMs in a given cluster were put in that cluster based on, and that would be presented in the form of the words that each TIM were familiar or similar. Sorry, I didn't say that right, but so for each TIM, there's a set of words that are significant for that set, and all these TIMs share that same set of words. Another possible scenario for a solution would be an automatic classification of a TIM. So the scenario I have outlined here is a user would like to determine which code issues were found by a static code analyzer tool and which are found by manual inspection. So this isn't necessarily a current way our TIMs are classified manually in our database, but it might be something that a piece of knowledge that would be useful, help us understand, how well are our tools being used. So the user uses the system to train a machine learning to classify issues, just a subset of issues, not every issue. And once we train that system, a potentially different user feeds the entire set of unclassified TIMs that we want to classify here into the system. And proposal is within 5 minutes, the system automatically classifies each TIM according to the model it had learned. And an analyst is able to view the classification of each TIM and determine if the TIM is appropriately classified. Other piece of data here that we would expect would be the system would tell us how confident it is in that classification. So that would help an analyst in terms of having to not have to go through every TIM that was classified, maybe go through the ones that the system itself would not incredibly confident in that classification. So the technology is there and it's promising, but I believe there are certain challenges with this technology. Challenges with respect to what are the right mining algorithms for our problem domain. What are the right machine learning algorithms? And it might depend on the type of classification that you want to do. what are the right libraries or engines that are currently on the market for us, because there are a significant amount of tools that are there. Another challenge is accuracy of having a tool automatically categorize TIMs for us. The accuracy may not be 100%. So that could pose a challenge for us in terms of cleansing the text before it is automatically categorized. What ways would we need to cleanse that text? Maybe take out words that we don't want the categorization tool to use to determine a category for it. Let's see. Issues. I guess I talked a little bit in terms of issues containing text. I would throw off that categorization scheme. In a lot of cases for our TIMs, we include code snippets or requirement text as an example. Want to also acknowledge that our program here at the NASA facility has been exposed to this technology, and there have been a significant amount of work that we could build from here. And some of this work is identified here. Maybe one thing also that's not on this list was work that I was made aware of that was done recently with the by WVU on a developer's repository database. So that's a kind of an encouraging note here, is that we're not starting this from scratch, and we do have lessons learned to build from. Some potential next steps would be to basically just do some research, figure out what is the best text mining algorithms, text processes that we need for our solution. Perform trade studies on libraries and engines for a solution that we could use. Also, just start to describe and evaluate possible architectures for a solution. Reach out to organizations within the agency that are using data mining for their repositories, and partner with academia. One thing I wanted to point out is I believe it is promising for us to be able to mine TIMs in ways that we're not currently mining these TIMs for. But what I've found is it is even more important for us to maintain good writing practices of these TIMs to ensure that, for example, here they have our impact statements describe what can happen to the system capability, a specific system capability in the impact, that impact to the mission or safety of that system. And another example here would be recommended actions are sufficiently detailed without prescribing how to change the affected artifacts. And a couple of references that I used here to help kind of shape this presentation. Also would like to thank a couple mentors that I've had in my process as well, both at Carnegie Mellon and here at the facility. And I think with that, that's my last slide.
Okay, you have about 5 minutes for questions if you'd like to take them.
Okay.
When you mentioned 610 categorized clusters, are those categories that you can find, or is that something that the machine has that these kind are similar to their narrative that
Yeah, that process would be new categories that have not already been identified by the analysts. So this would be taken. The example would be take all issues that are related because they're both classified as incorrect code issues, and automatically breaking that down into, say, 30 categories. One possible category in that case would be null pointer, using null pointer, that sort of thing. Array out of bounds issues. That's, you're able to find, basically automatically separate that group of 600 into 30. Right. Now,
Hit your red button, please. Thank you.
Taxonomy of issues.
Clusters, or that would just be one project, and actually the other projects will be different clusters.
Well, that's the interesting thing is it doesn't necessarily have to be only on one project. You could build your input set to span multiple projects. That would I could see using this this technique to possibly build that taxonomy.
Is there any thought as far as linking it to external databases that are similar to this? Like, say, Osmo's got a database as far as different problems that were found over the years and defects. Is there any thought as far as linking those two potential, like say, Tim linking to potential problems that may result from that?
There could be. It's an interesting thought. I have not included that yet, but which database?
Like Osmo, the Office of Safety
Emission Assurance.
I know they have a big database of problems over the years. So, I mean, what I was thinking is, as far as we see the things here, but if these aren't implemented correctly or in some fashion, we could find results from Osmo, but vice versa. I mean, that's something that we haven't really looked into previously. It's just looking externally.
Right. Yeah. I guess I touched on that kind of generically in terms of using what we learned and basically reaching out to the community to inform others. So I would see that what you bring up as a good example of doing that.
Are there any questions on the phone?
As a reminder, to ask a question, please press star then 1 and record your name when prompted. One moment. No questions are currently.
Drop the hook.
All right. Listen until the breakout session.
Yeah. One more question in the room.
Okay. Yeah.
So for instance, if you're looking at the holy database or some other database, the tool you can introduce those and you would use some kind of processing to the material so that the tool could go through it if it was separate from the databases. Is that right?
Pre-processing. So you have to pre-process each issue in that database. You have to get that unstructured text into some sort of structured form. that was where I was talking about, using tokenizing and stemming in terms of a pre-processing step before you actually try to automatically categorize those issues into categories.
So you use test activity so that you can get your reasons. Could you use it across multiple databases?
Yes, the inputs that could be built by however many databases you need or would want to. That kind of, so that would have to be kind of determined about how you want to use this technology. How many databases do you have in your organization that you want to collate together? So if you want to collate issues from TIMS to the example that you have where on-orbit anomaly, when you want to do that together, you would have either build that input set net by hand or determine if that's a requirement you want to be done automatically.
Okay, I'm going to ask you if you need to continue to take it to the breakout room. We're going to go on with our next presentation. Thank you, Bill.
Thanks.
Good job.